Understanding units begins with the idea of a base unit. Every unit will originate from a base unit because the base unit, as defined here, is simply the fundamental unit for a measured quantity. Now, the important idea is that, as this tip says here, formulas use base units. And that's important because anytime we plug into a formula, we need to make sure we are plugging in the base unit. Now, the metric system has a series of base units for each quantity. And for the quantity of distance, the base unit is the meter. For the quantity of mass, it's the kilogram. And for the quantity of volume, it's the liter. Now, pay special attention to the fact that the kilogram is the base unit for mass. It is not correct to plug in the unit of a gram into the formula because the kilogram is the base unit and plugging in grams would be incorrect. Now, the metric system gets its power from prefixes. And these prefixes allow us to measure things that are very big and measure things that are very, very small by applying prefixes. So for instance, by applying the prefix giga in front of meter, we can measure something that's very, very big, 1 billion meters in size. And by applying the prefix nano in front of meters, we can measure something that is very, very small, 1/billionth of a meter in size. Let's practice some conversions using prefixes. In this first example, we're being asked to convert 10 kilograms into grams. Now, the method we're going to use is called the box method. And the box method always starts by writing what we're given, in this case 10 kilograms, over the number 1. We now need to figure out what to convert to get it to grams. In order to do this, we look in our table to find the relevant conversion. In this case, 1,000 grams is equal to 1 kilogram. We write grams on top with kilograms on the bottom so that the kilograms will cancel. Now we simply need to gather all our numbers together and then simplify them to arrive at the answer. In this case, 10,000 grams. In part B, we're being asked to convert 1,500 meters into kilometers. Again, we start by writing what we're given, 1,500 meters, over the number 1. Again, the relevant conversion is in the table. In this case, 1 kilometer is the same as 1,000 meters. This time, we write meters on the bottom so that it cancels with the meters from before. Now we simply need to gather all our numbers together, simplify to arrive at the answer. In this case, 1.5 kilometers. This last problem, part C, is going to require 2 conversions because there is no conversion from megameters to centimeters in the table. We start by writing what we're given, 0.23 megameters over 1. Now, the first conversion we're going to do is to meters, and so we look up in the table to find that 1 million meters is the same as 1 megameter. We write 1 megameter on the bottom so that it cancels with our previous megameter. We will now convert from meters to centimeters. In this case, we look up our conversion in the table. This time, 1 meter is the same as 0.01 centimeters. We write meters on the bottom so that it cancels. Now all we're left to do is gather all our numbers together and simplify to arrive at our answer, which in this case is 23 million centimeters.